Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important quantum mechanics concept, that is advanced quantum mechanics, that is a partial wave analysis. Already you know that what is the partial wave analysis. We discussed the previous video we uploaded, that is the Born approximation method. Now we are going to discuss about a partial wave analysis. What is the partial wave analysis? Once we have to see how the questions we have to solve in this video we are going to discuss. So this question was asked in CSIR December 2017. This question was asked for 5 marks question. So please remember, this is a 5 marks question in the advanced quantum mechanics question, right? A phase shift of 30 degrees is observed when a beam of energies of a beam of particles of energy 0.1 mega electron volt. First you have to write the data. So that data Kronecker delta 1, so that is you have to take it as a delta L1 is equal to 30 degrees for the energy of the beam of particles. E1 is equal to 0.1 mega electron volt. This is the beam of energy is scattered by a target. When the beam of energy is changed, so the beam of energy is changed, the observed phase shift is delta L of 2 is equal to 60 degrees. That beam of energy is changed. What is that? That one we need to calculate. Assuming that only S wave scattering is relevant. Which wave scattering is relevant? S wave scattering is relevant. S wave scattering is relevant. You have to take it as a S wave scattering is relevant. S wave scattering is relevant means orbital angular momentum quantum number is equal to 0, right? And so the cross section does not change. The cross section does not change means the total cross section does not change, means the total cross section does not change means it is equal to constant. So the total cross section is a constant, clear? So therefore does not change with energy. The beam of energy is equal to how much? The E2 is equal to how much they are asking. According to the partial wave analysis in terms of the phase shift, partial wave analysis, what we have to write it is, according to partial wave analysis, you have to take, according to the partial wave analysis, the total scattering cross section sigma is equal to 4 phi by k square into the total scattering cross section sigma is equal to 4 phi by k square is equal summation L is equal to 0 to infinite 2L plus 1 into sin square delta L. This is your total scattering cross section. But S wave scattering you have to take it as a S wave scattering you are going to write it is, if S wave scattering L is equal to 0, your k square is equal to 2me is divided by h cut square you are going to write it is. So therefore sigma is equal to 4 phi is divided by k square into L is equal to 0, 2 into 0 plus 1 into sin square, which one we have to write it is delta 0 we able to take. So therefore sigma is equal to 4 phi by k square into sin square delta 0. But k square you have to substitute here. K square is equal to 2me by h cut square. 4 phi is divided by 2me is divided by h cut square into sin square delta 0. So therefore sigma is equal to 4 phi h cut square is divided by 2m into sin square delta 0 is divided by E you are going to take. So now you have to cross multiply sigma into 2m is divided by 4 phi h cut square is equal to sin square delta 0 is divided by E. So sigma is does not change with energy. So 2m is a constant. 4 phi h cut square is you have to take it as a constant. So therefore constant is equal to sin square delta 0 is divided by E you have to write. So from this what we able to take it as a our expression you are going to get it as a sin square delta 0 is divided by E is equal to constant. So based on this what we have to write sin square delta 0 at 1 the first beam of particles that energy is equal to E1. So now the second beam of particles sin square delta 0 at 2 is divided by E2 we have to write it is. Now you able to cross multiply E2 is equal to sin square delta 0 at second beam of particles is divided by sin square delta 0 at first beam of particles into E1 you have to write sin square delta 0 E2 is equal to 60 degrees is divided by sin square so delta 0 is equal to 30 degrees into 0.1 mega electron volt. Sin 60 is equal to root 3 by 2. So therefore E2 is equal to root 3 by 2. Root 3 by 2 whole square is divided by sin 30 is equal to 1 by 2. 1 by 2 whole square into 0.1 mega electron volt we have to write it is. So therefore what we have 1 by 2 square get cancelled. Therefore 3 into 0.1 mega electron volt. So E2 is equal to 0.3 mega electron volt. This is the second beam of particle energy. So that is 0.3 mega electron volt. Once you have to see what is your option is equal to 0.3 mega electron volt. That is the correct option you have to take it as a. This is very very important. So if you really likes my teaching, you are really sync my teaching style, you have to choose our app. So we started in Quantum Online Academy app coaching, that is CSIR and GATE, DL, JL, assistant professor. So these are the after MSc who are preparing the competitive exam. So please try to utilize this chance. This content is very very important content. Nowhere you will get it in India. So like this content nowhere you will get it. Once you have to download our app, that is Quantum Online Academy app. After downloading our app, you able to see our courses CSIR and GATE physics course, JL physics course and DL physics course. So like that courses will appear in our app. So first you able to see these individual papers also available. First mathematical methods of physics we recorded and we uploaded all the classes. This is recorded one only now. So now classical mechanics, the whole recorded classes are available. Electromagnetic theory also according to your CSIR syllabus these whole classes are available. Now the quantum mechanics also core and advanced part is available. Almost one topic is there, that is the relativistic quantum mechanics is there. Maybe within 1 week I have to finish entire the quantum mechanics portion also. So for till now these 4 papers according to your CSIR and core and advanced syllabus. So these 4 papers are available. So please share and subscribe and like our YouTube channel. Inform to your friends who are preparing the competitive examination after the masters in the physics field. Clear? So those people will get the benefited. Maybe 5 more papers are there. So once we have to finish the quantum mechanics, we able to start in the next month, that is the statistical and thermodynamics paper I will start to you. So please utilize this chance. This is very very important. At a time single within 1 month we unable to learn the entire the subject. Once you have to download our app, really you have to listen the classes in our YouTube channel. Later you decided whether you want to join in the course or not, then only you have to take the course. Thank you so much.